Hello, I'm Mark, and welcome to part 3 of my Unreal Engine tutorials on how to add wings and flight control surfaces to your physics movement systems. So in continuing where we left off in part 2, and yes, that was a long one, let's do a quick little recap. So when I was originally intending to do this flight control systems videos, I really wanted to only do it in 2, but as I was kind of working through the blueprints in video 2, I found out that when we got up to about the hour mark, I still had about half an hour's worth of content to really go up cover. So I decided to split this off into two more video, or into another video. So let's do a quick little recap of what we did in part 2 before we move into part 3. So first off, before we get started, one of my viewers was kind enough to point out that if you're in Europe and you try to go to the Fab store looking for some of these Vigilant aircraft, that they're not there. But he did point out that you can actually get to them through Vigilant's own marketplace. So if you're living in Europe, or if you don't see it by clicking on the link and actually going to InFab, I'm also going to go ahead and leave a link to their website, so you can go ahead and go up there and take a look at what they've got and see if any of this kind of works for you, and play with it. So there it is. So I'm just gonna, that's my public service announcement. Let's move back into the video. All right, so leaving off, we went ahead and created our input mapping context for jets. So there it is. For jets, I'm going to be using the D-pad for throttle, and I'm going to be using an analog for my rudder assembly, and that's going to be on the left. We also went ahead and duplicated the physics asset so that we can make some modifications. First off, we went and clipped the constraints off the canards, since I wanted to be able to move those canards in the animation. Then we also went ahead and locked everything else down. So on the angular limits on the bones. If we didn't do this, pretty much this whole thing would become would ragdoll as soon as we went into simulated physics. So we went ahead and did that. There are ways to move these things without locking it down and keeping it, but again, that would require some custom animation, working in custom animation blueprint to have the animation engine fight gravity. So again, that's a separate video series, and we'll probably get to that some point. But for now, we're focusing on flight control and getting an aircraft up off the ground. And then finally, we went and took all these constraints and we went ahead and set them to simulated. So they were kinematic. We went and moved them to simulated, since we'll need that in order for us to fly this jet as a simulated physics body. Then we moved over to the HUD. We duplicated the drone HUD. We went ahead and made a couple of small design changes. Then that's the reason why I duplicated it, because we only need one throttle since we are going in the X direction. So that's what we have here. And then all I did in the get the PB throttle function, I just went ahead and moved this from the Z value up to the X value, and that's what it's going to be returning there. Okay. And then finally we went ahead and created our jet blueprint using a pawn class. And first off, we went ahead and set up our interface. So we used our BPI. Right now it's Heli HUD, but you could probably rename that to Vehicle HUD at this point. So that's just a common interface that we can use to kind of allow us to map the HUD controls to our actors here, which are using the vehicle simulation component that we're creating. And in doing so, we went ahead and updated the interface functions that are being returned back to our HUD. All right, so after that, we went and set up our skeletal mesh using the Typhoon fighter. We've set up the animation blueprint. We turned on the simulate physics, and I set our vehicle collision presets to vehicle. It's just my habit. It's a vehicle, so I set it to vehicle. All right, we added a spring arm, attached it to the joint, gave it a length and an offset, locked that down right behind the aircraft, but we also gave it some camera lag as well. Added a camera on there so we can see where we're going, and then created some afterburner, used the afterburner effects and that come with the aircraft. So we plugged those in so you can see the fire coming out the back. And then finally we got to the simulation component, and well, there was a lot of data to set up in order to get this to work nicely. So we set up our profile in our medium, and this is our air medium, and we're just going to be using the constant. We set up both static and gimbal thrusters, but I'm keeping the gimbal off for now. But so in case you wanted to then see what a vector controlled thrust would look like on your plane versus just using the wings and stabilizers. But yep, we set up our thrust, so one for each engine, same with the gimbal. And then we created our 4 configurations for our wings, and we created 2 profiles. That's the flaps up, and that's flaps down. And we did it for both left wing and right wing, and then we also created our tail fin as well. And this is kind of going to keep us, help straighten us out as we're flying through the air. And then we finally, came to flight control surfaces, set up our, where we set up our rudder. We created 2 for each canard, or 1 for each canard for our elevators, and then we created 1 for each aileron for our ailerons. So that's 5 controls. And then moving into the final piece, which is our throttle. So we set up our throttle rate. I'm using a 6 rise, 2 fall. And my rise rate and fall rate with throttle control enabled. So this is our sticky throttle. I'm going to just move it by 10% on each press, with an interpolation of 2 going on the rise and an interpolation of 1 on the fall. And I think that's it. We're not using anything in the rotation control. Okay, so now that we've got all of this set up, all the data set up, we can now move over to wiring up the plane in the event graph. So to do that, first off, let's go ahead and get our mapping context for our input mapping. So to do that, we're going to tie into the receive controller changed event. There it is, receive controller change, and as you notice there's the old control and the new control. So this event fires every time the controller on the actor changes, so on the pawn or the character. So this is something you could tie into if you were doing something where your character is possessing a mount, you're going from a character to a vehicle and from a vehicle back to a character, right? This is how you can then go ahead and, when you do that change, it will then go ahead and, that possession, right, it will then fire this event, and this is where you could then also do some addition things on that controller change. So from here, we're going to focus on the new controller. We're going to say cast to player controller. So let's make sure that we want to make sure that if this is coming in, this is the new controller coming in. You have the old controller. That way, if you had an AI controller, right, you may want to put this AI controller in a temporary variable. That way, it doesn't get overwritten. And then you could then say, when you unpossess it, we can then fall back and use that same controller again if you wanted to do that. So that's why we have 2, the new and the old. Then from here we want the enhanced input subsystem. So there we are, get enhanced input. As I found out, if you're doing networking, you also want to do an is valid. Otherwise, you might see some errors in your blueprints. So we want to make sure that this is valid before we actually use it. Apparently this does get called a couple of times on networking, and for some reason you can have a player controller one time and not have this, but then when it gets called again you can have a player controller with the subsystem and then it works. So we're just making sure that we only do this. This allows us to catch this event. And then from here we're going to say add mapping context. So let's just go ahead and do that. And the map we want to use is the plane. And I think that's all we need to do for this. So that is our mapping context. I'm just going to move this up here. And we can go ahead and put a comment around that if we want to. We'll call this input mapping, and there it is. All right, next up is begin play. So I'm just going to move this up to here. So on begin play, so let's I want to do a cast to the blueprint that the skeletal mesh is doing. So I want to get the animation engine in the skeletal mesh. So I'm going to grab skeletal mesh, say get animation instance. There it is. I'm just going to put that down there, and then off here I'm going to say cast to BPA. There's our animation. So that's what we want. That's the instance that we want to interact with. And then from here I'm just going to say promote this to a variable. And let's just go ahead and cut this down a little bit. And just call it anim instance. Alright, so that's the animation engine. So since I want to animate all the control surfaces, we're going to need access to this to do that. And then from there, we need the HUD. So to do that, I'm going to say get controller. And then I'm going to do a cast to player controller. So I'm using get controller instead of using the get player controller, and the reason why is because I want to see if this controller is a player controller, because it could be that if this is an AI, then we don't want that. We don't want the HUD to show up. So this is going to do that check to see if we have a player controller, and if we do have a player controller, then I'm going to say create widget, and the widget we want to create here is going to be the WB jet HUD. And from here I'm just going to say add to viewports. Okay, so, and then finally, I want to start this plane with the flaps in the down position. So I'm going to just use our new set foil shape function that we created here. So I'm going to set this to if successful, but I'm also going to have on cast fail. So we still want this to be done regardless. So if the cast fails, i.e. it's an AI, you can still start with the plane, the flaps in the down position, and the down position is in that array is at value 1. So there we set that. Okay, so next, let's see. So I'm going to hold off on the afterburner stuff since we don't have that defined yet. But I do want to. We will come back to here and get the set the afterburner as well, so we can set it in the off position. But I can go ahead and set the visibility. Let's do the visibility first. So for the afterburner, I'm just going to go ahead and grab the right afterburner and say set visibility. And I can do this for both afterburners, so I can just pull the left and the right in together in the blueprint. And just check that, and we'll check that as well. So new visibility and propagate to children is set. Alright, we'll hold off on anything else for now. Let's see, on actor overlap, we're not going to need that. Alright, so moving to the next piece of this puzzle. Before I do event tick, I think we need to go ahead and set up all of the animation, events and functions. So let's get started. I'm going to start off with just the parameter updates that we need to make for the jet. So to do that, we have our animation instance, so let's go ahead and create these. So I'm going to start with the rudder first, because a lot of this is probably going to be, we can just copy, paste, and change some variables. So add custom event. I'm going to create a new custom event. Let me zoom in a bit. So this is our set rudder, and this is going to be the, I'm just going to keep it generic. I'm just going to call it angle. And this is going to go ahead and be a float. So for our rudder, what we're going to do is we're just going to go ahead and run a map range. Clamped. And within that range, our rudder can go, you know, from one extreme to the other, so it's going to be -1.0 to 1.0. So what this is going to do is it's going to go ahead and take the inputs coming in, and it's going to reinterpret that as the output. And so the output is going to, we want to be is 60 or -60 and 60. And then from here, based on what I was looking at, I'm going to put we're going to need to put a multiplier of -1 in there to kind of get it to go in the right direction for us. And then let's pull the animation instance. So within the animation instance, there are whoops, no, we don't do that. I want to get the animations. There is a lot of variables that it's using, and those variables are publicly accessible, so we can actually get access to it. So we want the set rudder angle. Just going to go hook that up, and we're going to set it to that. Alright, so that's setting the rudder. So the next thing is going to be our stabilizers, which is our elevators. So to do that, I'm just going to go ahead and I'm just going to copy this for now, and I'm going to give it a different name. And I'm just going to say set elevator, and because we're going to, it's going to be the same angle for both of those elevators. So we are going to want to, since they're going to be going in the same angle. So Val's going to come in, and that is set to the stabilizer, so I'm just going to go ahead and grab the animation instance, say get, and so there's going to be a left stabilizer and a right stabilizer. So I'm going to say set and I'm also going to do the same thing for right. And I'm just going to pull, tell you what, we'll just pull that variable there. Put a little reroute node. So the value coming in, this will set our elevator or stabilizers. And again, here I'm going to set this to 20 since we have a min and a max of 20 degrees. We might as well just keep that in line with the animation. So that should do our stabilizers. So our ailerons are a little different because, or should be a little different because we want them to kind of reverse. So we'll split those out. So again, I'm just going to go ahead and just copy this real quick. So this is going to be another clamp. So we'll start with a set aileron left. And again, this is -1, 1, -20, 20. Go grab the animation instance. So I get, and I'm going to say set aileron left. And we'll just park that in there. And we'll take the clamped value and put that into there. And then I'm just going to go ahead and duplicate this again, and I'll just put this over here, and this is going to be set aileron right. And again, just it's the same values. The only difference is it's going to be oops, no, need the animation instance first. Get. And again, we'll just connect the dots. Alright, so that's our ailerons, that's our elevator, and we also want flaps, and flaps kind of both, again, they both go down at this, together, so I'll just grab this. I'll just put this over here, and we'll call this set flaps. And this is going to go from 0 to 1, and here we're going to have 0 to 45. So that's the down angle of the maximum flap extension. And then from here, we're just going to go ahead and again grab our animation instance, since that's where all the variables are. And we're going to say set flap left. And while I'm here, I'm going to say set flap right. that in there. And I'll just run this same value off there. Recompile. There we go. Alright, so that should get us the rudder, the elevators, the flaps, and this is the ailerons. Alright, so there's another animation that this thing has, and it has the exhaust nozzle, so we can play with that. Oops, add custom event, set exhaust, and we'll call this set exhaust nozzle. And for that, again, it's going to take an input parameter, and this is going to be scale. And then again, another map clamp. And we're going to go from 0 to 1. And the scale that seems to work best is 6 to 1. And then there's a little bit of math before we get that into the Niagara events. So this is going to set the exhaust nozzle, but it's also going to allow us to set the actual afterburners as well coming out of the system. So to do that, let's see, we have the exhaust nozzle, so let's go grab the animation instance. Nope, I want the set. There it is. Just gonna put that there, and that's gonna take the clamped value. Just gonna run that there real quick. Alright, and then there's going to be some math needed to kind of get our exhaust to look nice coming out of the engine based on the size of the aperture. So to do that, let's go ahead and grab the afterburner. I'll start with the right. So we want the vector 3. So they're using a vector 3 variable that we want to have control over. So that's the one we want. And well, this is by string. I think there's one by name, which is the one which I think we prefer to have. There it is, that's the one. And the variable name in there is going to be this jet wing scale. I'm just going to go ahead and split this since we need to kind of move the widen those evenly. So the way that this is going to be calculated, so we have x, y, and we have a z So to do that, we're going to first do a multiply, and that multiply is going to go into the X and the Y, and that's going to be by 7. And then off the Z, we're going to then multiply that again. So this is the depth, and that is going to be multiplied by 1.1, and we'll just park that in there. And we want to do this for both left and right, so I'll just grab the left and the right, just plug those in. And then off here we also have a second, so this is the ring, now we need the jet scale. So from here again, I'm going to go pull the right out and say, so you know what, I'm just going to go copy this. Just going to grab this, hook that to there, and hook that to there, and we'll change to use the other variable. And for that one, it's just going to come out here. We're going to multiply again. It's going to reroute node, make it look a little less messy. So this is going to be by 0.6. And that's just going to go into the X. And then the Y and the Z is going to then be further multiplied by 0.2. Okay, so that should do it for setting the nozzle. It's a little bit complicated, but that should then sync the nozzle ring, the exhaust ring, with the Niagara particle effects, depending on how much exhaust you want coming out based on the aperture of that exhaust nozzle. All right, and then finally, we just need to be able to turn the afterburners on or off. So we just need a function called setAfterburner. So add custom event. And we're just going to pass in a Boolean parameter on this one. Is active, and then I'm just going to grab this and just say set active. So when we engage the afterburner, we should see the effect, and when we unengage the afterburner, then the effect should come off, and that's going to be based on this Boolean value coming in. Move this up here. Alright, so that should be everything for the almost everything for the animation. I think we just need a couple more things. Yep, just one more. And that has to do with the flap position. So we'll go and add this one. So this is set flaps. Add custom event. And this one is just going to take a delta time. And the way this is going to work, I want to bring those flaps to come down smoothly and come back up. But this is going to be done based on a button press. So it's either we're bringing them down or bringing them back up. So to do that, we're just going to run an interpolation. So I'm going to need to get two more variables. I need current flap position and target flap position. And float. And I'm just going to duplicate this for targets. So from here, I'm going to say current, get current, F in. So I'm going to be using the interpolate to constant, and the reason why I want to use this is because I wanted to have it have a uniform down and uniform back. So it should kind of look the same. It should have the same speed coming down coming down from when it starts to when it finishes. And so I'm going to say get current, target to target, delta time to delta time, and speed. We're just going to keep this as a 1. And then off here, I'm just going to grab current again, and we're going to set it. And then from here, we're going to then say set flaps, which is this one here. And from there, we're just going to pass in the angle. And then that should then go ahead and do that for both the left and the right from that function. All right, so now that that's done, we can, here, I'm just going to go ahead and update the on begin play. I'm just going to add the set afterburner function. So I want to start the afterburner in the off position. So we're going to be starting flaps down as if we're about to, getting ready to take off. So that's going to be there. And then event tick. I'm just going to pull this up. So this is so this is everything that I want happening on the game thread from the context of the vehicle. So here I'm just going to grab our vehicle simulation, and I'm just going to go into there and say get current vehicle state, and we're just going to go ahead and split this all out. So we've got some new things in here. We have our flap position, so this is going to be constantly being set when we go and change it, but we don't need access to that right now. But I do need access to the our X throttle value, because that's what we're going to set our exhaust nozzle to. So from here we're going to say there it is. Oops, missing the H there. Let's go and fix that. So that's going to be coming off our throttle position here. Okay, just save that. And then I'm also going to have a greater than, so for me, I'm going to be setting it so anything over 0.9, I'm going to turn the afterburners on. And if the throttle is less than 0.9, then the afterburners will turn off. It's just my preference. And so from here we'll say set afterburner. So if this is true, we'll turn it on. If it's false, we will turn it off. And then finally, I want to set the flap position, set all flaps. And regardless of whether the afterburner is on or off, and for that I need the delta time off the delta tick. Okay, so that should do it for hooking in all of our animation. So let's go ahead and set up the flight controls so we can control our plane. So first off, let's go ahead and start with the throttle. So IA underscore. And so again, we're mapping off throttle X. And I'm just going to go grab our simulation component, and I'm going to say set throttle input, map it to X, put that in there, and then drag this and drop that into there. Next I'm going to do the flaps. So I'm going to run IA underscore, where do we have that? Flaps. There's our flaps indicator. And for here, I'm going to run this off a flip-flop. So what this is going to do is it's going to just say, it's going to track its state. So its first state's always going to be A, but once A is fired, then it's going to set it to B, and then back to A, back to B, back to A, back to B. So that's kind of what that's going to do. And for there, I'm going to then just say target flap position. I'm going to say set, and so this is going to control our animation. I'm going to set that to 1. I think I'm going to go ahead and just default the tap flap position to 1, because that's where I want it to start in the down position when we start. And then finally, we also need to set the flap position there it is, set the force shape. So when we click on this, we want to set the force shape as well, so that our simulation uses the right force shape. So I'm just going to copy this. So what we're going to do is we're going to assume we're in the down position, because that's where we're starting. So when we click the button the first time, it's going to take the foils into the up position, which is our 0. And then if we click it, we're going to put it into the down position, and this will then set that setup. So that should then move that into position. So let's just compile that and save. Alright, so that should do it for throttle, and that should do it for flaps. So let's go ahead next and get the pitch roll in yaw set up. So for pitch, so let's tie this into the pitch system. So we'll go grab simulation again, set pitch, and I'm just going to pull that in there. But when we set the pitch, we also want to go ahead and just move everything. So to do that, we've got our functions. So I'm going to say set stabilizer. What do we call this? Oh, so set elevator. So this should set both of them, since elevators go down together and up together. So we're just going to do that, and we're just going to do that. Just going to close these. Alright, so that's pitch. So roll is going to be a little different, and the reason why, and that's part of the reason why I wanted to split it up. So our roll is our ability to kind of roll the plane using the ailerons. So IA roll input, and we're going to then say vehicle simulation, set roll input. And so for the left roll, we'll take the value as is. So I'm just going to pull this and park it into there and put a little reroute. But for the right roll, I'm then going to take this and I'm going to then multiply it by -1 because we actually want the animation to go in the opposite direction. And we can do that just like that. Alright, so that's the elevator, that's the aileron, so now we just need to do the rudder. And that's our yaw input, vehicle simulation, set yaw input. So we're just going to go ahead and do that. We're going to do that. And then we just need to do the set rudder. Alright, so I think that should do it. We have pitch, roll, and yaw. We have our throttle. We have all of our animation hookups. We've got our things that we want to run over time, as well as our begin play setup. So I'll just do a quick overview. Alright, so let's test this all out and see where we're at. So I'm just going to hit save. Let's go into the... Okay, so before we go into flight testing, I was going over the numbers real quick since this is getting more and more data heavy, and I noticed that I accidentally left out the force point location bone socket name on the right wing. We had it for the I have it for the left wing, but the right wing, he was missing for the right wing, and because of this would have created two different lift points on, one on the left wing, one on the right wing, which would have caused which would cause performance issues in the actual lifting performance of your wings. So just make sure that before you get started, just go back into the data, go under the right wing, and just make sure you've set the bone socket to the center of gravity, just like we did for the left wing. And then, so that should even everything out. So let's go ahead and move over to flight testing. I'm just going to go ahead and just move this over here. And let's bring up our map. We're on the lake bed in the desert. I've got debugging turned on so we can kind of see some of that data flying over the wings. So let's go ahead and power up. So as we power up, we're bringing her up, going to full military power, afterburners are on, and the plane's taking off. I'm going to bring the flaps up, which will then increase the performance, and I'm just going to go and take the afterburners off now that we're in the air. We've overcome the friction of the ground. And so now, we're flying. We can roll with our ailerons. We've got our pitch and yaw. So we can take her down, bring her up. Gonna try and loop her over. Hopefully we'll get enough speed before we crash. Okay, good. And then we can bring the rudder in to create a more aggressive yaw. So there's our rudder getting us turned in, and we can rudder it out. All right, and everything looks good. So this is using the static engine setup. So we can do a quick little test. And so I'm going to ramp her up to full power. We're about 1,000, 1,500. So I'm going to go do a loop-to-loop. And hopefully we won't crash into the desert floor on the way back. And yeah, so that did it. At 1500 we're up to about 10, maybe 12. But as you can see right now, based on the contrails, you know, it's, well, as you can see, this the afterburner is kind of going through the metal. I'd probably move the afterburner sockets a little bit further back, going at this speed, but hey, you know, it works. All right, so now let's go ahead and test this using thrust vectoring. So I'm just going to go ahead and bring the blueprint back real quick. I'm going to go ahead and just turn the debugging off. And I'm going to come up to static, and I'm just going to turn the statics off, and we can turn the gimbals on. So this is going to be, you know, like those fifth gen, some of those fifth generation fighters that have like that fifth, you know, that vectored nozzle in the back. So we're going to try and emulate that a little bit. I'm going to make that 5. Give us a little bit more on the yaw angle, and I'll make this one 5 as well. So it's 5 up and 5 pitch and 5 yaw. I'm going to just turn on the negated. Alright, so let's give this a test. So let's power up. Bring in the flaps. And this is using our thrust vectoring. So our pitch angles, it definitely feels like it's attacking the pitch a lot more aggressively. Yeah, and let's see if we can do a loop test. So I think we were at what, 1500 units off the desert floor. So we'll get to 1500 and we'll see, and it's coming around pretty quick. Woo! Yeah, just barely brought it out. And then let's add the yaw. So yeah, you can definitely see that that's definitely pulling that aircraft around a lot more. With the camera angle, you can definitely see it's kind of pulling it out of center because of the aggressiveness of that turn. Yeah, we'll put our afterburner back on. I'll bring this back down again. All right, so I think that should do it. So, you know, with the quick little adjustment to make sure that the left ring and the right ring are balanced, the lift seems to all be working. There we go, and flaps are down, we're slowing down, and we're getting more aggressive lift at slower speeds, which is what flaps are supposed to do. And that's all working nicely. And we'll put the flaps back up again, change the profile of the wing, and we're now designed for speed and maneuverability. Alright, so again, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to the channel, and I'll catch you in the next video. Cheers, bye.